Hey guys and girls, so in today's video I'm going to be talking about the modulus operator and explaining how it works. A good way for me to show you how the modulus operator works would be to plot it on a graph. So let's first simply add x, so we can see that x goes from 0 to 1 to 2 to 3. And now I'm going to use the modulus operator, so I'm going to say mod x, and I'm going to do it at a value of 1. And now we can see that x goes up to 1 and then loops back down to 0 and then goes back up to 1 again and then loops back down to 0 and continues like this forever. If I change this 1 to a 2, now you can see that it goes up to 2 before it loops back down to 0. So now let's do the modulus operator inside of Roblox. So I'm going to create a loop that goes from 1 to 20, and I'm going to print the I value with the modulus operator to the value of 5. And if I now run the game, we can see that it prints the values 1, 2, 3, 4, and then it loops back to 0, and then 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So the first thing you may be asking is, we have a value of 5 here, so why is it looping up to 4 and then going back to 0 instead of going up to 5 and then going back down to 0? If we look at the graph once again, when the x value goes up to 1, it goes back to 0, but this value at the very top here is not actually 1, it's 0.999999. So as soon as it touches the 1 value, it's set to 0. And the same is true if we have this set to 5. As soon as it hits 4.99999, it's set back to 0. And that is the reason why we don't see the value 5 here, because once it's past the value of 4.99999, it goes back down to 0. You will also notice that we're slightly offset from the loop. So instead of being from 0 to 4, 0 to 4, at the very start we're from 1 to 4, we're missing the 0, and at the very end we have an extra 0 at the end, so we kind of offset from the modulus loop. To bring ourselves into sync with the modulus loop, I can deduct this 1 to 0 and deduct this 20 to 19, and if I run the game once again, now we can see that we're in sync with the loop. So we go from 0 to 4, 0 to 4, 0 to 4, 0 to 4. And instead of going from 0 to 4, if we wanted it to go from 1 to 5, we can just simply add 1 to the end. And if we run the game once again, now we can see it goes from 1 to 5, 1 to 5, 1 to 5, 1 to 5. Now let me show you some things you can do with the modulus operator. For instance, let's say I want to create a grid of 32 by 32 parts. So I'm going to first create a variable called size equals 32. Now I'm going to work out how many parts I need to create my grid. So that was going to be 32 times 32. So I can just say amount equals size to the power of 2. Now I'm going to loop the amount. So I'm going to say for I equals 1 to amount do. And if we remember from before, in order to be in sync with the modulus operator, we need to deduct 1 from these values. So I'm going to deduct this to 0, and I'm going to deduct this by 1. And now I'm going to use the modulus operator to calculate the x coordinate. So I'm going to say local x equals I, and I'm going to use the modulus operator with the value of size. And to work out the z coordinate, I'm going to say I divided by size, and then I'm going to round it down to the nearest whole number. And finally, let's create a part, and let's anchor the part, and let's set the part's position to the X and Z coordinates, and size the part and parent the part to the workspace. And if I run the game, we can see that we was able to use the modulus operator to create a grid of parts that are 32 by 32 in width and height. Thank you for watching the video, and if you have any questions, feel free to leave a comment down below.